Welcome to Swell Academy. It's the logarithm here, and we're working with my properties, product, quotient, and power. Just gonna try to introduce you, talk about a few examples, special cases like always. Product property is this idea that if you're adding two logarithms with a similar base, then essentially you could rewrite this logarithm of this base with m times a variable n, or maybe we would look at it as log b of mn, can be rewritten as such. There are proofs for this. Log base xcd can be written in an inverse order or reverse order of that, where you could expand this to log xc to log base xd. So if you see in this case, we contracted or simplified, and in this case, we expanded in a sense. Um, there are other kind of funny ways you could look at this, like, well, I know 24 I could say is 6 times 4, so I could, if need be, because sometimes you have to manipulate numbers, log 8 base 8 6 plus log base 8 4. Just kind of like a funny way to look at it. Oh, well, I don't see any product property here. Well, no, 24 is a product of 6 and 4, so let's see if we could do that here. If you see product property, but you're not quite seeing, a base, a common base, the idea is this is a common logarithm with a base of 10, so this just becomes log s plus log c, and the idea is instead of writing the base 10 here, we're just assuming a log c is a log base 10. We work in tens and hundreds, so using a base 10 of a logarithm seems like I want to work back to quotient, skip the slide there. Here we have quotient property, um, kind of related to power property in the sense that power property is multiplication and addition, where the quotient property is division and subtraction. So in this case, the log b, previously the power property, we're adding these. Now quotient property, I'm sorry, product property, we're adding them. In this case, quotient property, we are now subtracting them. And same as goes the inverse. If we have this subtraction here and we're looking to contract where here we expanded, you're just doing the inverse of what we did previously, and we can rewrite this as log x a divided by b. I did think this was a good example to bring up. You have a log base 10, that's assumed, okay. And some may say, okay, well, do we have product property down here? No, you have log 13. And both the x and y are dividing, so you're actually going to subtract not only the log x, but you're going to subtract the log y. I think that's something worth taking a look at. And then to look at here, I'm sorry, example, our property is power property. We are taking a look at power property. There's a few extra here that I added because I think this is a commonly used one. Logarithms deal with exponents. You have an exponents deal with logarithms. You have your exponential form. You have your logarithmic form. So now basically whatever is m is raised to a power, this can be brought to a coefficient of the logarithm. So in this case, I can rewrite this as n log base b m here in this case. So basically what you're seeing is that we're taking our coefficients and our exponents and saying that they're maybe interchangeable, they're movable in a sense. So, inversely, we could say log base x b, I could raise this to an a power because I'm taking this coefficient and bringing it to the front where I took this exponent and brought it to a coefficient. Good little example here, which I like, is, well, I don't necessarily have an exponent here. Well, we continue to see this idea that when we deal with pre-calculus, there is this need to convert a square root or a cube root, so on and so forth, to x to the 1/2 power, x to the 1/3 power, putting this number here on the bottom. And we want to do the same thing here and say this is 5 log base 8, 5 to the 1/3. And we do this in order to, let's add this color here, I like this one here, add this to our coefficient here, so we can rewrite this as 1/3 log base 8, 5. And same, I looked at this just kind of, you may be in a situation where you actually can take this coefficient, give it an exponent, and because we're dealing with numbers, have a log base 8 to the 16. So we're going to actually, enforce the exponent here. And then another good example would be, oh, well, I have log base x 16 to the 1/2. I'm finished. No, remember, we converted a square root of x to a 1/2. So you could do the same and say 16 to the 1/2 can also be converted to a square root of 16, which I could say log base x square root of 16, which I could say log x. It's just this idea of just showing you kind of all these little nuances and little pieces that could be floating around that you may not see at first. And all of these cases, all these B's and M's and N's that we've brought up, and certain, certain rules being like, these always need to be positive, always positive. So in all these kind of examples where you see the base and M, always positive. So all these numbers we're working with have to be positive. And then if you have a base, if we're working with these product power quotient properties, these bases are a couple little rules you need to abide by as we're working through our properties of logarithms. Remember, the more you fail, the more you succeed. So go out there and seek some failure and experience some success. See you soon.